Lesson 2.3, Simplifying Variable Expressions. This is a very important lesson, just like the last one. In fact, it's going to be using the distributive property here very soon in the process to simplify variable expressions. Now, the first thing we're going to talk about is a key idea in algebra called a term. Now, I've got a couple different definitions, although the second one is more of a definition for something we'll talk about later on called a monomial. A term is part of an expression that is added. I also listed or subtracted because we remember subtraction is the same as adding the opposite. So if you have a subtraction sign, that's the same as adding the opposite, like plus and negative. So it's still part of the expression that is added. The second definition says that a term is a number, a variable, or the product of a number and one or more variables. And as you will see, for our intent and purpose, that's what we're going to be looking at for terms. Now I have an expression right here, 6x plus 2x plus 7. And as you can see, I've underlined 1, 2, 3 terms. I've got it labeled. You can see that they're being added in this expression to one another. Those are terms. Now I took the first term here, 6x, and I brought it over here. And I wanted to make mention that 6x has two parts. You can clearly see the variable. But this number in front of the variable, that's times it. Remember, 6x means 6 times x. That's called the coefficient. Sometimes it's called the numerical coefficient because it's a number. This one, this term right here, its numerical coefficient is 2, and the variable is x. In this expression here, this term doesn't have a variable, so it's always just 7. We call that type of a term a constant term because it never changes. With a variable, it can vary. With a constant term, it stays constant. Now, there are terms and there are terms, and what I mean by that is when we define the following idea of what we call like terms. Now, another name for like terms is similar terms. Most books just call it like terms. Like terms are terms that have identical variable parts. Now, the variable, meaning like in this expression here and this expression here, see how they have just x? These are considered like terms, 6x and 2x. 7 is not a like term because it doesn't have the variable, these two do. Now, I'm going to write down here, if I write down 6x squared plus 2x plus 7, I just changed it a little bit here, put the x squared. There are no like terms among these three terms, this term, this term, and this term, because even though they have the same variable, this is being raised to the second power. So it has to have an identical variable part. If this is an x squared, for this to be a like term, this would have to be an x squared, for these two to be like terms to one another. So that part is key. Now, if you're asking about constants, all constants are like terms. When you add a constant and a constant, of course, you just get another constant. Here's an example. Identify the terms, the like terms, the coefficients, and the constant term of the expression. Well, in this one right here, I'm just going to abbreviate just a little bit. The terms are 3x, 2, and 5x. Remember, the terms are what's being added. The like terms, okay, would be the 3x and the 5x because they have the same variable part. The coefficients, well, that would go back to the terms that have the variables. This doesn't have a variable, so it's not a coefficient. The coefficients would be the numbers that are times the variable, so that would be 3 and 5. And then the constant term, well, the constant term is 2. Now, it's a little bit trickier over here because I have 5 terms in this expression. 1, 2, 3, 4, 5. And this expression has some subtraction signs. Remember, subtraction is the same as adding the opposite. So when I go to list the terms here, I'm going to list 27. I'm not going to list 13t. I'm going to list negative 13t since subtraction is like adding the opposite. 32, negative 2t, 10t. Now, my like terms, I have two sets of like terms. I have the constant terms that are like, that's the 27 and the 32. And I have this term, and this term are like terms because they all have a single factor of t. So I'm going to list negative 13t, negative 2t, and 10t. My coefficients, that goes to these guys. They're the numbers that are in front. So that would be the negative 13, the negative 2, and the 10. And my constant terms, And in this case, I have two constant terms. I have 27 and 32. Okay, hopefully that makes sense. Now we want to learn how to simplify a variable expression. By the way, I forget to mention it. It should be automatic. You should be taking notes on the instructional video. You should be writing down the key ideas, the key steps, like what's coming up here, and of course the examples and how the examples work. So you'll have something to refer to when you're working on your assignments and preparing for your test. All right, now to simplify a variable expression, there are two steps. You eliminate parentheses, and that means you're going to use the distributive property, which we talked about in the previous section. And you're also going to combine like terms, which is what we talked about just a minute ago. So what we're going to do is we're going to work some examples that may require just this step, may require just this step, or both steps. But we're going to look for this one first, then we're going to do this one. And I started off with the two examples that we just did when we were labeling the different parts. The first example here, remember, these are like terms. So I have no parentheses. I combine my like terms. A positive 3x plus 5x is 8x. The plus 2 does not combine because it doesn't have a variable. You can't add an expression with x to an expression that doesn't have it. You can only combine like terms. You should say this with me right now out loud. You can only combine like terms. So that's my answer right there. The whole thing is not 10x, it is 8x plus 2. The next expression over here. I have some like terms. Now it doesn't matter if you start with the constants or you start with the variables, but I usually put the constant term last. So I'm going to start with the variables. Remember the minus 13t and the minus 2t and the plus 10t? The minus, remember, it's like adding the opposite. This is a negative 13. This is a negative 2. This is a positive 10. I see a subtraction sign, I think negative. I see an addition sign, I think positive. A negative 13 and a negative 2. Remember, when you add two numbers that are both negative, you add them and keep the sign as if you add them as if they were positive. So that would be 15 and a negative 15t. These two right here. Negative 15t. Now I have a negative 15t and a positive 10t. A negative and a positive subtract, take the sign of the bigger, so that's going to give me a negative 5t, and that's the first thing I'm going to write down as a negative 5t. I combine these three terms, this is what I have. Now I have two more terms to combine right here and right here. I'll just kind of double underline here. A positive 27 and a plus or a positive 32. Well, 27 and 32, that's 59. Positive or plus 59. Doesn't go any further. This has a variable, this one doesn't, you cannot add them. Now, when we get to multiplying, you can multiply just about anything, but when you're adding and subtracting, they must be like terms. All right, now this next example here is the first one that has parentheses. Remember the first step? You eliminate parentheses. Before you combine like terms, you eliminate parentheses. And we're going to use the distributive property. Remember this from just the last section there. 5 times 6 is 30, plus 5 times x is 5x. Plus 4x minus 9. Notice I don't multiply the 5 times this stuff here because it's not in the parentheses. But now it's a problem like the last couple. I have like terms here and here, and I have constant terms here and here. So a plus or a positive 5x, a plus or a positive 4x, that's 9x, a positive 9x. Now if you're going to get confused after you've combined them, a trick is kind of cross them out so that you don't somehow combine them again. You have a positive 30, you have a minus or a negative 9. A positive 30 and a negative 9 is a positive or plus 21. And that's my answer right there. Now this one is almost as simple, except when we distribute, we have to be very, very careful with our signs. Look over here now, you see the parentheses? We've got to eliminate those, and there's a 3 in front that we're going to distribute by. But that 3 has a subtraction sign in front of it. Remember I said when I see subtraction, I think negative? So when I distribute here, the first part I don't distribute, that's just 4m plus 12. When I distribute here, I'm not multiplying by positive 3, I am multiplying by negative 3. Negative 3 times 2m is negative 6m. I'm going to write minus 6m. Negative 3 times a plus or a positive 2. Negative times positive is negative, that's a negative 6. I'm going to write minus 6. And now once the parentheses are out of there, I combine like terms, just like I was doing before. I have like terms here and here, and I have some constant terms which are like terms to one another here, there, and there. So the 4m and the minus or negative 6m, this is a positive 4 and a negative 6. This is where knowing your rules for adding positives and negatives makes this much easier. I don't have to grab a calculator. I don't need to get scratch paper. I can do these in my head. A positive 4m, a negative 6m, that's a negative 2m. So again, just so I don't get confused, I'll cross those out. And then here I have a plus or a positive 12, a minus or a negative 6. A positive 12 and a negative 6 is a positive 6. So plus 6. And that's my answer. Remember, once I get it to this point, I know I'm done simplifying. There are no longer any parentheses. There are no longer any like terms. This one down here, there's parentheses, but there's no number in front of the parentheses, just a subtraction sign, which is kind of unusual looking. I don't think we've come across one like that yet. In that situation, when there's no number following the subtraction sign and in front of the parentheses, you can put a 1 in there. And then you can think of this, like I did here, as a negative 3 that I distributed by. I'm thinking of this as a negative 1 that I'm going to distribute by. So I have 15x. A negative 1 times 10 is a minus 10. A negative 1 times a plus or a positive 15x is a negative 15x. Now this one's kind of weird. I have like terms. I have a positive 15x. I have a minus or a negative 15x. These are opposites. They cancel out. That's 0x or just 0. So these cancel out. That's the first time we've come across that. And I'm left with minus or negative 10. And that's my answer. One more like this. This one is a little bit simpler. There's not as many subtractions. I'm going to distribute by a positive 2. That would give me 14. Positive 2 times a minus t, that's like a minus 1t is a minus 2t, plus 14t minus 11. Okay? When your variable does not have a number in front of it, and I should have probably stressed this a little bit sooner than just right here at the end of the lesson, but if your variable, let's say for my example, my variable is x, if I say, what's the coefficient of x, there's no number written in front. That's like 1x. If I have the opposite x, or minus x, and I say, what's the coefficient of this expression right here, this term? It's like a negative 1 is my coefficient. So here with the t, the minus t, that's a negative 1t. 2 times negative 1t is minus 2t, and then I have 14t and 11. And I'm going to combine like terms. I have like terms here and here. A minus or a negative 2t, and 14t is 12t. A positive of 14 and a minus 11, a positive and a negative. You subtract, take the sign of the bigger, I'm going to have a plus 3. And there's my answer. Remember this little trick with your variables. If there's no number in front of the variable, it's understood to be a 1, or if there's an opposite sign, a negative 1. Now the last example is just an application, and we already know how to find perimeter. Perimeter, you add up the sides. So it says write and simplify an expression. So the first thing I'm going to do is I'm going to add the sides. I'm going to add that side, and this side, and this side. I'm going to add those together. Now what I have is a variable expression, and I have 4 terms. These are all like terms. The coefficient here is 2. The coefficient here is 1. The coefficient here is 1, just like I was saying a minute ago. So I'm going to have 2y plus 1y plus 1y is 4y. And then my constant term here, plus 4. Now these were like terms, so I could combine those. This one wasn't a like term. It didn't have the variable. All right, and with every lesson, remember, practice, practice, practice.